Good morning, everybody. Thank you for taking your time to join us this morning and learn a little bit about AquaCUT, our relative permeability modifier. My name is Akshay Singh. I'm the product manager for production enhancement for pressure pumping for Baker Hughes. I will be co-presenting with me today will be Kimberly Land, who is the R&D team leader for production enhancement. Also on the call today is Henry Lee, who is our senior applications engineer for production enhancement. Henry is joining us in case there's any technical questions that may arise, and he'll be able to answer those in the Q&A session. Also today moderating the webinar is Naima Spur, who's a technical manager for production enhancement. Both Naima and Kimberly Land were critical during the development phase of AquaCUT, and I want to thank them for taking the time today and joining us today during the presentation. Now, during the presentation, if you may have any questions, please feel free to type them in as you think of them on the Q&A on the right side of your screen. You have the option to either write them with your name representing your question that comes along with it, or you may put it in anonymously. With that being said, thank you again for taking the time, and we're going to get started here talking about AquaCUT, and we're going to go through how AquaCUT was developed, what it is, and how we apply it in the field and what kind of results we have seen. With that, before we get started on AquaCUT, I want to take a brief moment to go through our water conformance portfolio at Baker Hughes. We provide both non-selective and selective solutions. Some of our non-selective solutions are listed on the right, that are zone safe, seal gel, gel block, and magna block. These solutions do not differentiate between the production phase of whether they're oil or hydrocarbon or water phases. They will shut off all production from the same zone, and some of these are actually irreversible. Today the main technology that we're going to cover in our presentation is a selective technology, which does differentiate between the production regimes and behaves differently when it comes into contact with water, and also behaves differently when it comes into contact with hydrocarbon. This is our AquaCUT relative permeability modifier. Both are selective and non-selective applications or products can be placed using a bullheading or a coiled tubing type applications. Before we get started on the actual product and technology itself, it is very important to understand the source of the issue. AquaCUT is designed to address the subsurface water production issues that you may have in your mature sandstone fields. Now, understanding how the AquaCUT works, it's important to understand what your reservoir is doing at that time. We need to understand where the excess of water is coming from. We need to really understand if it's an actual commingled flow zone, or is it a layer flow zone where the two production regimes are different, and that will basically help us select either a non-selective solution or a selective solution. Now, once we understand where the source of the water is, we also got to keep in mind that we cannot create oil where oil does not exist. So the expectation has to be right, the reservoir has to be right. As and when we develop this application for AquaCUT, we also make sure that we have a thorough process in place in identifying the correct candidate for AquaCUT. And our applications team will go through all the data that we collect from our customers and be able to tailor make that application towards the well itself. And in the end, after we pump the job, it is extremely critical to be able to evaluate the results. What you need to understand about AquaCUT is one of those technologies that will show you immediate response after you put your well back on production. But the main benefit of having AquaCUT is to understand how it behaves in the long run and how we can tweak the application and make sure we learn from the first well how we applied it, what results we see, and be able to have a full field deployment of AquaCUT. With that, I'm going to start now on talking about what AquaCUT is and how the AquaCUT works. AquaCUT is Baker Hughes's relative permeability modifier technology. We used to have a legacy offering, which was AquaCon, and we then went ahead and took about few years to develop a technology that would outperform our previous incumbent. So that being said, we took our time to develop this technology. There was a long time when we were not offering a relative permeability modifier, and we wanted to make sure that the product that we come out with is the one that is actually needed by the industry and will help you address your subsurface water concerns. So AquaCUT is a hydrophilic, high salt tolerant polymer. It has unique anchoring sites for longevity. Now, this is a critical point to understand. The unique anchoring sites for longevity allows the AquaCUT to have a chemical reaction at the rock level, which helps it form a covalent bond to the rock and allows it to attach itself to the rock. Which is disrupting in the way we look at it, is because that mechanism that allows it to attach differentiates the technology from what we have present in the market, where technologies just simply coat the rock. So understanding that, and understanding this basic principle, and when we ran at different cycles, when we were developing the product, which Kim is going to go over in shortly, we were able to see that the AquaCUT application at lab scale level, at least, lasts longer than what we had seen the previous technologies do, which is where we are hoping that the longevity of this application will allow you to have lesser interventions or lesser reapplication of the technologies in the future. AquaCUT is a water-based treatment. AquaCUT can be placed both through a bullheading or a coiled tubing application. Coiled tubing is mainly geared towards specific zone placement. Currently, what we have with AquaCUT is it mainly targets sandstone reservoirs. We are working on a carbonate solution that we hope to have out maybe in the later Q3 or Q4 of this year. AquaCUT, like I had mentioned earlier, is a selective technology, so it works in a commingled oil and water zones. Currently, for the application of AquaCUT, it is effective in sandstones with the permeability ranges between 10 millidarcies to 2.5 darcies. And also the temperature ranges between 120 degrees Fahrenheit to 250 degrees Fahrenheit. Now, the temperature boundaries that are set here were set for the scope of testing and what we have seen in the field application. So if we have reservoirs or wells that are above the temperature range here, we will be happy to validate that with further testings and make sure AquaCUT is applicable. Just because your reservoir may not be within this temperature range doesn't mean AquaCUT will not work. We just need to validate it. That being said, let's cover now some of the features and benefits of AquaCUT. So AquaCUT, like we said, the intent here is to reduce the water hydrocarbon ratio. It addresses the subsurface water production, which immediately will help you reduce your disposable volume of water that's being produced, which is water, and help maintain or increase your production of oil volume from the current state of the well. And what that helps our operators do is basically cut down on the logistics and the treatment costs and the hours spent on disposing of that water. The unique anchoring sites for longevity of the application will help operators cut down on re-interventions that's required to repeat the application in order to continue to address the subsurface water issues. Now, when we are covering the unique anchoring, when I say the unique anchoring site, it's very critical to understand, which I'll get when I'm talking about the application of AquaCUT, is to understand why the pre-flush is important. We need to make sure that we allow AquaCUT a clean rock to be able to go in and have enough time to interact with the clean rock to be able to form the chemical reactions and have the chemical bond. And again, AquaCUT is to selectively reduce water productions while maintaining hydrocarbon productions. We will show you this in the slides coming up on where we had proven it in the lab. And then again, in the end of the presentation, we're going to quickly go over some results that we saw in the field trial. It will help improve your economics by minimizing both water disposal, treatment, and transportation costs. Another thing about AquaCUT is that it can be applied in a rigorous application. It requires a very low footprint on location and not excessive horsepower and the other complications that come with it. With that being said, let's understand now how the chemical mechanism of the RPM actually works. So with the picture on the right, if you can see the arrows pointing and the green arrows pointing top and bottom, you can see a thin layer of a polymer that has swollen up, which this basically indicates as the water production comes into contact with the polymer itself will swell up and fill up those pore throats. And in doing so, AquaCUT is extremely water wetting. It will not only, which helps it also to further impede the flow of water into the wellbore. Now, as the production regime changes and the water is then displaced by oil, if you focus to the picture on the right, the polymer itself will lay back down, as represented by the green arrow. Now, as I mentioned earlier, that AquaCUT itself is extremely water wetting, which then allows the hydrocarbon to further be produced smoothly through the wellbore. And this will keep repeating itself as the regime changes. Now, when the water comes back in, the polymer will swell up, invert those pore spaces, and impede the flow of water. And when the hydrocarbon will come in, it will lay itself back down and allow the hydrocarbon to flow through your wellbore. With that, I'm now going to turn it over to Kim Lant, who is going to talk about the testing that went behind developing AquaCUT.
Thanks, Akshay, and good morning, good afternoon, good evening. In the next few slides, we'll discuss how we measured the performance of AquaCUT in the lab using regain permeability testing on sandstone core. These results include two regain permeability test methods. The first method is a typical regain permeability measuring oil and water regain, which measures the water and oil response as one phase displaces the other in the core. And the second test method is a single phase, in this case aqueous, regain permeability for acidizing applications. All testing was performed on Berea sandstone at 93C and 200F. The order of the fluids as they went into the core are an initial saturant water, which was usually brine, initial perm to oil, initial perm to water, followed by an injection of a pre-flush in the treatment with a shut-in. And then the regain was measured with 2 to 3 cycles of water and oil. In the next slide, we'll see the summary results of those tests. This data represents the average regain permeability test after cycling oil and water after the AquaCUT treatment. The cycles show the effect of AquaCUT water and the oil response in the core, which validates the repeatability and the longevity of the treatment. As mentioned in the previous slides, these tests were conducted with water and oil, establishing initial permeabilities, then treating with the pre-flush, then AquaCUT, then the shut-in time, 24 hours. The mechanism of AquaCUT is selective, like Akshay said, and that successful treatment will impede the flow of water while allowing oil to pass. This core flow testing has shown that both of these parameters were met in the regain cycles. The regain permeability cycles show significant reduction in water permeability while maintaining most of the oil permeability. Cycling oil and water in this method creates an effect that is more harsh and dynamic than dual phase flow, which also confirms that the polymer is effectively expanding in the presence of water and contracting in the presence of oil. Results also show that the regain permeability to water decreases to less than 10% after treatment, as seen in the chart. The water stabilizes immediately post-treatment and remains constant and low after the second and third cycles at less than 10% regain, showing effective polymer reaction as well as repeatability and longevity. The regained permeability to oil yielded 90% or more of the initial oil permeability. The oil recovery is steady, and testing shows that it keeps improving over time in all regain cycles. These results show effective polymer application by 90% or more of the oil to pass through consistently in these cycles. Now, although it's not shown in this chart, we did want to mention that we had regain permeability testing also conducted with gas and water. Those results showed a 90% plus regain to gas, which can also continues to improve over time, and a 15% regain to permeability to water in repeated cycles. On the next slide, we'll discuss in more detail the regain permeability of the acidizing and AquaCUT treatments. This testing is specific water regain permeability just to see the effect of the acid treatment in the aqueous phase as it relates to AquaCUT. These tests show the recommended application for using AquaCUT as an acid stimulation with an acid stimulation, as well as using AquaCUT to remove, using acid to remove AquaCUT if that need should arise. The left chart shows the effect of an acid stimulation treatment followed by an AquaCUT treatment. It begins with an initial brine permeability measurement of potassium chloride as baseline, followed by an ammonium chloride to displace potassium chloride and prepare for the acid treatment. The acid treatment is a common acid sequence consisting of a pre-flush, a main acid, and a post-flush, followed by another ammonium chloride sweep, whether that acid treatment was successful. In this case, it was, returning about a 144% regain permeability. The core was then treated with the pre-flush and the AquaCUT and shut in for 24 hours. The following regain brine permeability was measured, and a percent regain was calculated to be 7%, reducing the water by 93%. So this was not only a successful acid stimulation, but a successful water conformance treatment. On the right shows the effect of treatment following an AquaCUT treatment. An initial brine permeability measurement with potassium chloride was made as a starting baseline, then a pre-flush, the treatment of the AquaCUT, and a shut-in overnight. Regain brine was measured, and a percent regain was calculated at about 8%, reducing water by 92%. This was followed by an ammonium chloride sweep to prepare for the acid treatment. It was a common acid pre-flush, main acid, post-flush, followed again by the ammonium chloride. And you can see that the ammonium chloride regain was much higher permeability than the ammonium chloride directly after the AquaCUT treatment, showing that this acid treatment most of the AquaCUT treatment. Now, while these are general results, we are happy to discuss applications that are specific to water issues in your sandstone formations. Please post any questions in the Q&A. And now back to Akshay for talk about treatment design.
Thank you, Kim. Now that we have covered what AquaCUT is and how we developed and how we tested the performance of AquaCUT in the lab, it is now critical to understand how we design the treatment for your application. With that, the more information that we can get in the front end about the reservoir, about the well, would only help us tailor-make a solution that will give the best opportunity for successful application for AquaCUT. With that being said, we require a certain data requirements which are essential for such applications with which our Baker Hughes applications team then goes to work and comes out with a flow design and a pumping schedule that will be applied for AquaCUT. Now, these parameters, some of them are listed on the left-hand side, range from production history to wellbore and completions diagram to understanding the reservoir, understanding the rock, the net pay, porosity, temperature, any logs, and if possible, oil samples. We also recommend from time to time, if we do have a difficult rock that may be outside of our testing scope, if we can get some core samples sent, we'll be able to run those core samples at our lab, and we can come out with a design that's basically tailor-made for that rock. With that being said, the snapshot that you see on the right-hand side, it's a document that we send out, and if you think AquaCUT is something that may be applicable in your operations, feel free to reach out to us, and we will send you this packet that requires the necessary inputs for the data. And then like I mentioned earlier, the application team will then get to work on it and decide if this candidate is actually a good fit for AquaCUT. Is it an actual candidate for a selective RPM, or you are more in need of a non-selective water shutoff treatment? Just remember, the accuracy of data allows for a successful treatment and placement of AquaCUT. The more information we have in the beginning will help us better define the success criteria better, and be able to have a better and be able to flawlessly execute and have the desired production results post applications. So just example of what we do after we get that data, right? So the one thing important to understand is when we learn more about the rock and the samples of the wellbore fluids that are being produced, we are able to design a spearhead fluid volume. And as I had mentioned earlier, this directly relates to the longevity aspect of AquaCUT, where we need a clean rock. So the spearhead fluid is basically designed to go ahead and clean the rock the best it can, which then allows for AquaCUT to go in and attach itself to the rock by forming the covalent bond. We then designed a treatment to have at least we designed a treatment to have a penetration of about 10 feet into your wellbore. Now we do know that AquaCUT is still works in the ranges of invasions between 4 to 10 feet, but we always target a 10-foot radius of penetration for AquaCUT. The flush fluid volume is designed just to make sure that AquaCUT is completely squeezed out into the formation and to the bottom of the perforations. Again, all of this is designed in the front end. All of the testing will be done in the front end before we go ahead and pump AquaCUT in the field. So whenever we get the information back, our applications team will work with the region engineering teams or with the operator directly to basically design this job to understand how AquaCUT can be applied in the well and then ultimately in the field. Now, with that being said, now we have gone through on what AquaCUT is, how AquaCUT was developed, how AquaCUT jobs are designed. So why AquaCUT? AquaCUT is designed to increase your sellable volume and decrease the disposal volume. It is meant to bring your well economics back to where the entire field we hope to bring the economics back to more favorable into more favorable conditions. AquaCUT again is designed for longevity of for the longevity of the application. And this is basically going back to attach versus coat differentiation of the products that are available in the market. AquaCUT does what we have told it's supposed to do with a lower footprint. All of these three things then basically relate directly to the energy transition aspect of AquaCUT. AquaCUT is developed and is tagged as one of our energy transition products at Baker Hughes. Energy transition products, it does so by reducing the disposal volume, which basically reduces the water treatment and the requirement of surface facilities to be treating those waters, and as well as the logistics behind disposing the production of water, as well as less repeated interventions with lower footprints. Now, AquaCUT is a young product. We have pumped it the first job was pumped in Q4 of last year. And since we have pumped it, the operator is extremely satisfied with the results, and we have since then pumped it 4 or 5 more wells in a short period of time. And with that, I want to kind of just share a little bit of a snapshot of that case study. The field trial well was a identified well in South America. It was a high permeability reservoir, and post application of AquaCUT, we were able to double the oil production and reduce the water production by 700 plus barrels of water per day. Now, this was substantial for the operator, and the operator was extremely happy with the results that he was seeing. Now, AquaCUT is one of those products that as soon as you apply, you put the well, you shut in the well, and you bring the well back on production, you will see the response immediately. But we also need to understand is that we need to continuously monitor the well to understand how AquaCUT behaves as the production rate stabilizes, and see how long stays active in the well, which Kim has shown in the different cycles that we had repeated in the lab. It's pointing towards a positive direction, that the previous incumbent to this technology that wouldn't perform as well as AquaCUT now does. We hope that those results in the lab can be mirrored in what we see in the field. And that with AquaCUT now gaining more popularity, we hope to see the customers then take this application from one well to entire field. And with that, we want to make sure that we're able to at least bring your EOR back to where it was, and at least extend the life of your reservoir the best we can by turning the economics back to green and reducing your disposal volume overall for water. With that, we have now covered the presentation section of AquaCUT. And now I would just remind you, if you have any questions, to please go ahead and type those in the Q&A bar, in the Q&A section on the side. I see that there's some questions coming in. Now we will basically answer those questions to the best we can, and as time permits. So to you, Naima, please let us know what our first question is.
We have a good set of questions, and the first question for you, Akshay, is about sharing the presentation. Can we share the presentation with our audience? And what is and I think all those questions are coming in as anonymous. So would you please detail how the person can get in contact with you so that you can share the presentation?
Thank you, Naima. As this is an open forum, if you do want to reach out to us, please reach out to us on any of our emails that I'm now showing on the webinar itself. Reach out to us directly, and we'll be happy to share this presentation with you. And then we can also set up a one-on-one calls and basically get into more technical details that we weren't able to cover on this presentation, and then understand what your direct needs are. But yeah, I mean, we do have customer presentations available. Reach out to any one of us, between me, Henry, Kim, and Naima, we'd be able to address that. That's not an issue.
Thank you very much. So the next couple of questions are going to be for Henry. It's more about the application. With the first question will be, how do you calculate the volume of AquaCUT required to pump into the zone to be effective on shutoff of water producing zone? So this is question number one. Question number two, how often do you have to apply the AquaCUT?
The first question, in terms of how much volume do we need to pump, as Akshay had mentioned, we strive to go radially about 10 feet into the formation. So for this, we need to calculate the volume of rock, or the volume of porous space that is going to be in 10 feet. So we need the height, we need the porosity, and then we need the the radial penetration, which is usually 10 feet. For the second question, which I believe is, how long does it last? Yes, because of AquaCUT's nature, and which is an improved version of all the products that are previously in the market, because of the covalent bond, we strive that the product will last more than 3 to 6 months.
I think I'll go back on this to Akshay with your case history. Do you know the longevity of the current product, and when do you think, for the well that has been pumped, when do you think those wells are going to need a second application?
Thank you, Naima. So again, like we said, this is a young product, right? And now what we have tested in the field, what we have tested in the lab when we developed in this product with the different repeated cycles. There's no way to directly correlate that or to basically, have a direct correlation on what that will do to your field, right? Because every reservoir is different, your production velocities are different, and to quantify a water shutoff and the longevity of it can only be proven while we continue to monitor the production. So understanding that, what we had pumped in the first well, we're still seeing that AquaCUT is still very much present and still very much doing its job. And as Kim had mentioned too in her slides, that once we start monitoring this data, and what we hope, we want to be positive about this, we want to be extremely optimistic about this, but we also want to manage the expectations the best we can. With that being said, I would just want to make sure that what we are seeing, what we saw in the lab test, we have basically repeated those results in the field with the initial response of the well, and now we are hoping that what we saw in the lab testing, where we're thinking, it could, like Henry said, 3 months, 6 months, it could be a year. You just don't know just yet, right? So we're going to continue to monitor that, and we're going to start building a case histories and all the data sets, and then which then we'll be able to write papers on and be able to share with you all in the future. So hopefully that answers that question.
Thank you very much. There are a lot of questions about lab testing, Kimberly. And before we get to the lab testing, the first question is to explain the difference between selective and non-selective solutions. So that's your question number one. The question number two is about the core flow testing, and it's about the conditions, temperature, pressure.
Thanks,
Can you
Naima.
explain? Okay.
Yes.
Thank you.
Okay, so the difference between selective and non-selective water conformance. Selective is what AquaCUT does, where it allows oil to pass where it traps, well, not traps, but it impedes the flow of water. Non-selective means that it doesn't matter what fluid or what phase is present in the pore space, it's going to stop it. So the product Zone Safe that we have would be a non-selective treatment, because it completely shuts off production, or shuts off production to everything in that zone. AquaCUT is selective in that it allows the oil to pass while impeding the flow to water. For the, we didn't go into a lot of detail about the core flow, because at a high level view, we're more than happy to go into more detail if you'd like to have one-on-one meetings. But I can tell you that the testing that we did for the results that you saw today were on Berea sandstone that were about 800 millidarcy. The test temperature was 200 degrees Fahrenheit or 93 C. And the net overburden for most of these was 1,000 pounds.
Okay, thank you. Thank you very much, Kimberly. There are a couple of questions about the the formation wettability conditions, and one is about would this work in water wet wells, and the other one, if the formation is oil wet, would this work? Can you take this question as well, Kimberly, please?
Sure, thanks. Absolutely. It doesn't matter what the wettability is, because we're going to prep the surface for the treatment. That either with an acidizing treatment or with a solvent treatment, to make sure that we clean all the rock grains off so that we get the best adherence for the covalent bond of the polymer.
Okay, thank you very much. Actually, Akshaya, in how many wells were, how many jobs were done so far, and how successful were those jobs? Would you please comment on those jobs? That's question number one. Question number two, how is this different from AquaCUT? We have someone in our audience who used to be with BJ Services, and he had pumped AquaCUT. And how? So, would you please comment on those two questions?
Right. Thank you, Emma. So, how many wells we have pumped it in? I can say comfortably we have pumped it in about 5 to 6 different applications to date. That being said, we were only allowed to share the production results of our first field trial well, and which is what is published as a case history on our landing page that you can access, and I'll give you details for that after the end of this Q&A session. And you should, and as I'm sure you understand that we're working with permissions with the customer. As soon as we get those permissions out, we'll be able to publish further case studies and be able to write some SPE papers and publish those as well, right? So from what I could share up to now was the first well that we pumped the AquaCUT in, and the results were doubling oil production and reducing 700 barrels of water plus per day. And as soon as we get further permissions to start publishing the rest of the data, we'll make sure that's made available on our landing page. Now to the second question about the difference between AquaCUT. So, like I mentioned earlier, for the longest time we weren't in the market with an RPM post AquaCUT, and which was for a reason. We took our time with this technology. We wanted to get it right, and we spent a lot of hours. People who started this project have moved on to different roles, and we finally came out with a product that we are really excited about of bringing it to the market, right? So the main difference that I can see to date that we have seen when we compare it to what AquaCUT used to do is that this product is an improved chemistry, if not a better chemistry. And the reason I say that is because it works better at lower concentrations, number one. And number two, and what we're seeing is that if we look at the cycles that we're running it through, we run the core through, we do see the longevity of this treatment also pointing in that direction. So compared to AquaCUT, those are the two things that we hope we saw AquaCUT outperform AquaCUT in the lab scale, and we're hoping to repeat that in the field and be able to write those case studies in the future. I hope that answers the question.
Thank you very much. So the next question reads, AquaCUT shuts off water producing zones and improves oil and gas production. Could gas production increase to the high level where high gas production could eventually restrict oil production from the well? How can we mitigate or prevent this risk? I'm going to start with Henry on this question, and Henry, after you comment, please pass it to Kimberly for her comment.
Yes, thanks for the question. Yes, AquaCUT will reduce the water flow into the well. It will allow the hydrocarbons to pass on. Now, if there is a concern with increasing gas, that's a different issue where AquaCUT is not going to help us. Kim, would you like to comment more on that, please?
Hi, Henry, thanks. Just to further your note about AquaCUT can only do so much. I mean, it does a lot, right? But it's definitely not going to create a water block, but it also isn't going to help if you end up with a gas issue. That's something else that we'd have to address at that time.
Okay, thank you very much. There's 3 questions are applied for application questions. So the first question is, can AquaCUT be used as a diverter in either matrix or acid treatment? 2, can it be applied in a proppant frac treatment when the water zone is close to the treatment interval? And 3, is AquaCUT effective for the zones that produce thousands of water per day, barrels of water per day?
Thanks, Naima. Interestingly, in the wells in which we have been pumping AquaCUT, we have seen a diverter effect. So we don't want to advocate that AquaCUT works as a diverter, but the initial results are very encouraging. We have seen pressure increases as the AquaCUT goes into the formation. In terms of prop and frac, we're in the process of validating the results so that we can apply AquaCUT in fracturing treatments. We have not done so, but it's part of our launching of the product. In terms of reducing thousands of barrels of water per day, we have the experience in the wells in South America, where we decrease the water by about 700 barrels per day. So that is very encouraging in terms of reducing the amount of water that the wells produce. Akshay, would you like to elaborate on the prop and frac application, please?
Thanks, Henry. Yeah, sure. So as we were deploying the product out, the initial thought was to make sure the product, we wanted to limit the scope of the research and development of the product, right? And we want to make sure that we are able to successfully commercialize this product when we go out, and we make sure we prove out what it's intended to do as its basic application. So with that, when AquaCUT, we first pumped in the field, and we just started to do so, and we're seeing positive results. Our next step is definitely to start looking at conform frac and conform acidizing type applications. As Henry said, we have seen some encouraging results. We are now starting to validate those to make sure they're repeatable. And now if you have a need for that, again, our contacts are here. Send us the details, and we'll make sure that we're able to test it under well conditions and make sure we're able to at least predict what AquaCUT will do to the best of our capability before we pump anything in the well. But from what we have seen, there's encouraging signs, and what the incumbent used to do, and this one being an improved chemistry, I don't doubt that we'll be able to perform those operations or those type of applications. It's just that we need to validate them before we do so. And that being said, I do want to repeat that this is currently meant for sandstone applications only. The second phase is rolling out for our research and development team for production enhancement group, is to come out with a carbonate technology. And once we have finished testing on that, we are hoping to launch that in the later part of the year. I hope that answers the question, Emma.
Yeah, thank you, Akshay. And actually, there is a question about the carbonated. What makes this work for sandstone and not for carbonate? And the second part of the question: do you have any case history of trials on fracture volcanic formation?
Okay, so when we had, like, I'm going to go back to when we have to define the scope of the project, right? When we're launching a product, we had first decided that there was definitely a demand for a RPM type product in mature sandstone fields, and which is where we had built, the business case out, and we wanted to make sure this product works. And to do that, we basically tested, how the product reacts, that we know that it needs that silica to be able to attach itself to, and the clean sand to be able to attach itself to. Now, we are developing a carbonate product, and we just need to make sure that it works. And as soon as we're able to do that, as soon as we're able to validate and repeat those tests, we'll be able to launch that application in carbonates. Now, as far as the case studies go, like I said, what we have published right now is all we can share at the moment. If you do want to have a direct question and answering session on that, please feel free to reach out to us, because there's certain details we can't share just yet, but we can share what we see in lab test results, and we'll be able to talk to that more on a one-on-one type, or a direct, a more technology in-depth discussion behind that.
Okay, thank you very much. Kimberly, is this technology applicable for wells producing above 95% water cut?
Thanks, Naima. I would say yes. So long as you have some producible oil to justify treatments in such high water cut wells, we would probably recommend this. But it all comes down to what Akshay is saying, that we really need to discuss what you're understanding the reservoir first, and understanding what your needs are, so that we can address it properly.
Okay, thank you very much. So the last two questions are for Akshay. So the first question is about production. So how much increase in production do you expect after an AquaCUT treatment? So that's your first question. The second question is about pricing. What's the price of an average AquaCUT job?
Thank you for those questions, Naima. So to address the first one, right? Defining a success criteria for a water conformance product, like I mentioned in my presentation, it's a little difficult, and always, you have to be cautiously optimistic about what you define as a successful job. Now, when it comes to the sellable production, I'm sure that's what we are alluding to here. In the first field trial that we saw that we doubled the oil production. That does not mean we created more oil. All it means is that we were able to impede the flow of water enough to where the production then allowed for more oil to come out in the same time frame, right? So that's always the intent. Now, that's going to differ from well to well. We hope it does the same. We want to say, I'm going to come in here and I'm going to double or quadruple your production, but we can't, right? We have to be cautiously optimistic. What we're seeing is good, great, excellent, and we hope to repeat that. Now, as far as the pricing is concerned, again, like I said, this is an open forum. Please feel free to reach out to us, send us your well information, and we'll design a job. And depending on what the application team comes back with the pumping schedules and pumping volumes, I'd be more than happy to come out with a pricing structure and be able to price it all out. Again, pricing is different from operation to operation, whether it's bullheading, coiled tubing type application, or or if you're going in with what your pre-flushes would look like, how difficult it is to clean the rock, and those sensitivities have to be kept in mind before pricing is decided. So again, our emails are up here. Feel free to reach out to us, and we'll be able to answer those questions better one-on-one.
Thank you very much. I just saw a new question came in, and this one is for Henry. It's about the limits / rule of thumb of length of interval and perforation type for this application. Is there any limit, rule of thumb on length of interval and perforation type for this application? This is for Henry.
Yes, thank you, Naima. Yes, very good question. At this time, the rule of thumb, if we want to call it like that, we are limiting the height of the formation or the zone to be about 20 feet. We want to be able to pinpoint the treatment. If we spread it over a very large interval, the treatment, we're not going to have control of where the treatment is going. So it's best to have a reservoir that we can control where the AquaCUT is going to go.
Thank you very much. That was our last question. Akshay, why don't you please thank our audience and close the meeting.
Thank you, Naima. Thank you all for a very interactive Q&A session. I want to thank you all again for taking the time and joining the webinar and allow us to present this exciting technology. Like I said, it took us 10 years to come out with this technology again, be active in this market again, and we wanted to make sure that we put out a product that we are very proud of, and we are hoping AquaCUT does that for us and for you guys as well. With that being said, there's a landing page on here for bakerhughes.com/AquaCUT. If the product overviews and the published case studies are available on that website, so please feel free to access those. Again, our emails were there on the previous slide, but also on the landing page, it will allow you to reach out to us directly. So again, thank you very much. I want to thank the Baker Hughes team here for taking the time out and helping me present this technology. And thank you all again for joining us today. Thank you.